Alright, this is my first successful attempt at using 12 volt power supply to run a motor basically. This is special because I'm controlling the 12 volts, switching it on and off with 5 volt power supply, like power source. That 5 volts can come from like a microcontroller. Specifically, the MSP430 is what I've been using. During this project, I fried both my MSP430s, so I actually don't have them hooked up right now. But instead, I have something that will represent them. Basically, I have an old computer power supply, and it is supplying the system here with 12 and 5 volts. The 5 volts is basically a representation of the microcontroller. So here we have the 12 volts. 12 volts will be on the top rail here, and then here's the 5 volts coming in over here. So the 5 volts basically powers this little switch here, which each one of those white deals is a little switch. And then here's the actual motor that is controlling. We have the motor being controlled on the top by this P-channel MOSFET and on the bottom by this N-channel MOSFET. Of course, like, you don't need two MOSFETs in order to control a motor like this, but eventually I want to make an H-bridge. So an H-bridge, this being 1/2 of an H-bridge, these two. So I can turn this one on and turn this one on, and then the motor will run. If I turn only one of them on, if I just turn this one on, this one's still off, it won't run. If I turn this one on and this one is off, it still won't run. They both have to be on for it to run. So this is half an H-bridge. An H-bridge would be two more of these, basically over here, and that way you could switch the direction of the motor. Now, ultimately I want to drive the, let's see, where is it? Ultimately I want to drive this stepper motor with it. It's a pretty good sized stepper motor, and it's going to take about 12 volts to drive it. It's rated at 5 amps at 2.6 volts, so the power supply is going to be rated is going to give 12 volts, and so we're going to have to come up with some current limiting computer program so that it'll actually work at its rated voltage, or work at the 12 volts but at its rated current. And so this circuit's going to be able to do that. And the nice thing about these MOSFETs is they have very low resistance, so actually none of the voltage will be dropped across them. All 12 volts will be dropped across this motor. And I'll show you that later here with my little multimeter. Alright, so let's turn it off, and we'll start with the power supply here. Okay, so the switch, come on, focus, you stupid thing. Well, I guess it's not gonna focus, but you can see they're all off, kind of. Now we're gonna turn on the power supply, and nothing should happen except the power supply turning on, of course. So the fan's running over here. We can check to see the voltage that we have. Of course, I'm not really set up to do this. So right here we're running at 12.35 volts, and that's from the top to bottom of the bridge. Now let's get a reading across the motor. So that should read 0 volts right now, because it's off, and that's good. So yeah, now let's turn on the P-channel MOSFET. P-channel MOSFET is on. So there is essentially, we have 12 volts running through here, and it's basically waiting to get through this N-channel MOSFET. As soon as we turn that on here with this switch, the motor is going to go. Let's see if I can get it all here in one shot. So there's our 12 volt motor running. Now let's check the voltage across the motor. So it was reading 12.25 across everything. And we're reading 11.79. So, I mean, you're losing hardly any voltage over the MOSFET, which is nice because they won't heat up that way, because they're not giving off any heat or wattage. So that's good. And hopefully I can build this to demonstrate the H-bridge. That'll be in the next video. Alright.